To find the derivative of tangent, we wrote it as a quotient and used the quotient rule. But the quotient rule is for derivatives, not for integrals. But we can still write it as a quotient and try to use some sort of substitution. Because if you notice, the derivative of cosine is sine. So maybe some things can cancel out here and we can simplify this expression. So let's try that. So if we let u equal cosine of x and take the derivatives of both sides of this equation with respect to x, so du dx is equal to the derivative of cosine with respect to x. Well, what is the derivative of cosine? Well, it's negative sine, as we see here. And now we can solve for dx and plug it in here. So solving for dx, multiplying both sides by dx, and then dividing by negative sine of x, we get that this is equal to dx. So now let's plug this in for dx. So the integral of sine of x, well, cosine of x, we said that was u, so plug in the u, and then the dx is this negative 1 over sine x du. And notice these signs cancel, and we just get left off with the negative 1 over u du. Factoring out the negative, we get this negative integral 1 over u du. And recall that the integral of 1 over x is ln of x plus c. We know this because of this fact that the derivative of ln of x is equal to 1 over x. So we get this. The integral of 1 over u is just ln absolute value of u plus c. But what is u? Well, it was cosine. So that means that the integral, the final answer, is equal to negative ln of cosine of x plus c. But remember the power rule for logs, we can bring this exponent to the top over here and get this. But this is the same thing as a fraction, so we can write it as a fraction like this. But wait, what is 1 over cosine of x? 1 over cosine of x, well, that's secant of x. So we can just write it like this, ln of secant of x. So in general, we can say that the integral of tangent of x is equal to ln absolute value of secant of x.